All right. Good afternoon. It's 12 o'clock on Wednesday. It's time for the Iowa Learning Farms Conservation Webinar. I'm Matt Helmers with Iowa State University, faculty member in Ag and Biosystems Engineering, director of the Iowa Nutrient Research Center, and faculty affiliate with the Iowa Learning Farms. Again, Iowa Learning Farms is celebrating 20 years, so excited to be here. We've not been doing webinars for 20 years, but for a number of years. And I'm really excited to introduce our speaker, who's a return um, uh, presenter on this. I think I remember the last time getting excited about cocoa Ras when you talked about that. So
Yep.
we have Dr. Justin Glisan, that's the state climatologist with Iowa Department of Agriculture and Land Stewardship. He's going to talk about conservation practices through the lens of weather extremes and climate adaptation. And certainly, I think, as we can all recognize, we have seen many weather extremes in the last 12 months for sure. And so, with that, I'm not going to talk about that because I don't know anything about it. We're going to turn it over to Dr. Glisan. And if you have questions for Justin, feel free to type those in the chat box and we'll get those to him at the end of his talk. With that, Justin, the virtual floor is all yours.
Great. Thank you, Dr. Helmers. It's always great to see Matt, and thank you for the opportunity to give this presentation. A lot of information packed into this, so I'll get started. So our presentation highlights, I'm going to look at Iowa's climatological trends over the recent term we consider climatology, the last full 3 decades. So think of a 1991 to 2020 average. That's how we develop a baseline to compare our observations and determine how extreme things are. Then we'll look at wet and dry extremes, precipitation extremes, and then drought. We're just out of a 4-year drought, 204 consecutive years of drought across the state, the longest drought since the 50s. And now we're in the sixth wettest start to a year with 152 years of records. So definitely we're seeing the pendulum of extremes swinging back and forth faster. We'll look at some climate projections and implications on conservation practices, and then look at the adaptation practices that we can implement across the state in the agricultural sector and even in the urban space to mitigate some of these extreme events that we're seeing more often. And this is a picture I took yesterday of some
Justin,
cumulus clouds. Yes.
somebody brought up, I don't know if there's a way in the audio settings to turn up your speaker just a little bit because you're kind of quiet.
Let's see. Okay, then we'll look at climate projections and implications, kind of give us an idea of the trends that we're seeing and how they're building out into the middle of the century, and even some information towards the end of the 21st century. And then again, getting into those adaptation practices that we can use that will help keep the water on the landscape in times of dryness, but also help mitigate uh, in terms of flooding and these higher intensity rainfall events, the loss of soil, the loss of nutrients from our rich soils across the state. Okay, so first we'll look at temperature extremes. This is the observed temperature record, and this is the anomaly. So you take the average temperature, the expectation of temperature, and then you subtract it, and this gives you the anomaly. So how cold a year has been or how warm a year has been. And this goes back to the late 1800s. So if you go back into the 1800s, basically through 1920, we're seeing a colder than average behavior globally across the earth. And this is land-based instrumentation, also oceanic buoys, ships having temperature gauges as well. Then we get into the 1930s, the 1940s. The 1930s, a particularly warm year across the United States, the Dust Bowl era. And then we get into World War II era with a very strong El Nino, combining with the impacts of World War II emissions and that strong El Nino, a blip in the temperature record, almost a degree above average during the 40s and getting into the 50s. And then as you can see, as we move into the 21st century, year after year, we're seeing warmer temperatures. We're seeing a broad scale increase in temperatures due to anthropogenic forcing. that produces a warmer atmosphere. So think of a thicker blanket that allows more warmth to be collected in the atmosphere. And why temperatures is an important feature is this tells us how much water vapor is available in the atmosphere. If we look broadly across the United States since 1895, this is the temperature change in degrees Fahrenheit. So where you see those darker reds, that's where we have a degree and a half to 2 degrees above a temperature rise through the last century. Uh, when we look at Iowa, we've also seen temperature changes more in the northern part of the state. But you look across the northern upper Midwest and then into Alaska, those brighter, darker reds, that's where we're seeing a higher temperature increase. And this has to do with what we call Arctic amplification. The loss of sea ice in the Arctic allows for more solar radiation to be infiltrated into the Arctic basin, and we see warmer temperatures. That sea ice acts as a shield, reflecting a lot of incoming solar radiation. And as we lose the extent of sea ice, we both lose the capacity to remove some of that solar radiation coming in, but we're also getting sensible heat within the oceanic basin, relaxing the temperature gradients between the mid latitudes and the high latitudes. And that's where we see the relaxation of the jet stream and more persistent behavior in terms of either persistent dryness, as we've seen over the last 4 years, or very wet conditions, as we saw in 2018 and 2019 across much of the state. So if we look at the annual average temperature since 1895 for Iowa, the higher the peak here, the warmer the year, the lower the valley, the colder the year. That blue line is the trend. So basically, per decade, we've increased the temperature 1/10 of a degree. 1/10 of a degree increase since 1895 gets us to about 1.3 to 1.5 degrees increase since the late 1800s. Why that's important is warmer air produces more evaporation, but warmer air can hold more water vapor. We call it the Clausius-Clapeyron equation, a purely physical relationship that says any increase in the amount of heat in the atmosphere, we have more water vapor holding capacity. So 1 degree Fahrenheit increase in water vapor in temperature gives us a 4% more water vapor surplus in the environment. Why that's important is it takes more meteorological loading in a warmer and wetter atmosphere to produce a meteorological event. And when we do see those rainfall events, instead of those gentle quarter to half inch rainfalls that historically we've seen across the state, we're getting 2 and 3+ inch rainfall events more often. So higher intensity events more often. And of course, these have implications on agriculture and infrastructure, both in rural parts of the state and suburban and urban areas as well. Now, if we look at that precipitation change since 1895, what we're looking at, again, the higher the peak, the wetter the year, 1993 being the wettest year on record. Then we look at 2018, 2019, the 2 wettest years on record, followed by 4 years of drought. You go back to 2012, 2007 to 2010 were some of the wettest years on record. Then we get into a pervasive drought across much of the upper Midwest in 2012. So we're seeing wet extremes co-located with dry extremes on a longer time period, but we're also changing them faster. So if you look across the state per decade, we're increasing precipitation by about 4/10 of an inch per decade. Now, we're not seeing that moisture homogeneously across the state. We're getting wetter areas of the state. We're getting drier areas of the state. But overall, you look at the statewide average, we're increasing the amount of precipitation. Now, if we look at, I mentioned climatology, the last full 3 decades, we call that a climatological decade. The current climatological decade is 1991 to 2020. If we take the previous climatological decade and subtract it from our current, we can get an idea of the behavior over the last 10 years. So annual mean temperature on the left, precipitation change on the right. What you can see across much of the United States is a warming behavior over the last 10 years, anywhere from 2/10 of a degree up to a half a degree, depending on where you are. Slightly cooler conditions across the Dakotas and into Montana, which makes a lot of sense when you look at the precipitation behavior change. We're seeing more precipitation across the upper Midwest, particularly in the Dakotas, but also across Minnesota, Wisconsin. More cloud cover, cooler temperatures. So that ties in pretty good. But what we also have to think about is all that water moves south. And with Iowa's borders being the Missouri and the Mississippi River, the implication there is with a 15 to 20% increase in precipitation in the climate projections, more aerial flooding, more flash flooding as we move out in several decades. Now, if we look at proxy months for agriculture, April for planting, October for harvest, and then July as we're going through the physical maturity of corn and beans, tasseling of corn, we're seeing in the shoulder seasons, April and October, wetter conditions across a broad swath of Iowa. But what we're seeing in July, when we have the warmest month climatologically, a depletion in the amount of rainfall that we're seeing over the last 10 years. So we've actually cut that anywhere from 10 to 20%, depending on where you are. That has implications on drought conditions. If we get into warm temperatures with a lack of rainfall, we can get into what we call flash drought or rapid onset drought over several weeks, particularly in July and August. And this has implications on our row crops. So hope that doesn't update. Uh, that's why it's important to use things like cover crops, no-till practices to keep that water within the soil profile when we do start to see warmer and drier conditions, particularly windy conditions. I get a lot of questions on, are we getting windier? If you look at the literature, not necessarily at the surface, but higher up, the higher up we get with wind speeds, we can also get an atmospheric thirst to draw out moisture at the surface. So these are trends that we're monitoring in terms of our conservation practices. Now, if we look at precipitation extremes, and this set of information is part of the climate change impacts on Iowa agriculture that we worked with the USDA Climate Hub in Ames, Dr. Dennis Toddy, and state experts across Iowa and even regional partners to parse out this data. But our annual average precipitation has risen by over 4 inches through the recent period, with the greatest increases seasonally in winter and in spring. So we're seeing more rainfall in wintertime, but also more rainfall in early spring. 1.4 inches increase in winter, and then in spring 1.8. Now that 1.4 inch increase might not sound like a lot, but winter is our driest month, so that is a particularly significant increase in the amount of precipitation. Less snowfall, more rainfall in winter, as we're also in the fastest warming season through winter. Now, our extreme precipitation events, those events greater than 2 inches over 24 hours, are becoming more numerous. We've basically, the average has been 0.8 days. We've doubled that in the near term. So we're seeing wetter conditions, wetter intensity events more often. And this stood out to me, this next bullet point. 40% of the statewide rainfall that we get annually is coming from the top 10 wettest days. So the top 10 wettest 24 hours. 60% of the precipitation that we're getting is spread out on these lower intensity events. But to see that 40% of our annual rainfall or precipitation in general comes on 10 days tells you that we're seeing a shift towards higher intensity events. Also, Iowa's planting season, April through June, has been trending wetter as well, particularly buttressed by the earlier part, April and May being wetter, trending almost 3 inches above average since 2008. So if we look at central Iowa for 24-hour precipitation events, blue bar is historical, red bar is the last 20 years. The vertical axis is the frequency at which we see these events. The horizontal axis is the amount of precipitation that we get over 24 hours. I'll draw your attention to the left first. 89% of the time, we get those gentle rainfall events historically since 1895, 1 inch or less. Now, over the last 20 years, we've lost some of that probability and it's shifted further right. So if you look at those 3-inch plus rainfall events, historically, 0.01% of the time we get those over 24 hours. Well, we've tripled that probability. So even as a small probability, when you triple a probability, this is showing you something is going on in the climate system. Warmer atmosphere, more water vapor, higher intensity events. Now, if we look at a broader scale look at precipitation across the state, taken at a 5-year average, and this is observed annuals since 1895. Annual precipitation just over the last 16 years has been several inches above average. So you'll look back here in the 40s and 50s, particularly the early 50s, we see a dip in the amount of rainfall and precipitation in general that we're seeing. That is co-located with the last longevity drought that we saw, 1954 to 1959. But if you look at the oval on the far right here, that's where we see that the wettest consecutive years, 5 years, have been between 2006 and 2010, preceding the 2012 drought. Again, I mentioned if you look at the 2-year intervals, 2018 and 2019 were the wettest 2 years on record. So we're seeing a shift more broadly in the recent term of higher intensity events, but also more precipitation annually over those 5-year and 2-year chunks. Now, I mentioned the 2-year daily extreme events. The annual average number of extreme events since 1900 we see in this bar chart. You see there's variability there. The black dots represent the actual events. So if you look at the horizontal black line, it shows the long-term average of 1.5 days. A typical station would experience a 1 to 2 or a 2-inch event, so 1 to 2 per year. Since 2005, the multi-year averages of these 2-inch rainfall events has increased. Look within that oval, we've seen those bars are above the overall average. So in the recent term, we've been seeing wetter conditions, 5-year, 2-year, but also in those higher extreme events, 2 inches plus. Now, this has implications on runoff. This has implications on aerial flooding. We think of northwestern Iowa, just over 3 days in June, 600% of normal precipitation, in the old parlance, a 1 in 1,000-year event, or the annual exceedance probability of less than 0.01%. So we wouldn't see an event like that in a given year 0.01% of the time. So that shows you that we're locking in these higher intensity events more often. Now, we mentioned annually the amount of increase in precipitation. This is a function of increased spring and summer precipitation. So if you look at meteorological spring, March, April, May, and meteorological summer, June, July, and August since 1895, what we're seeing, 9.2 inches and 12.5 inches were the average for those seasons. If you look at the far right side of the bar chart here, we've seen an increase in those spring and summer rainfalls. Now, interestingly enough, if you look at July, and I left out the slide for time's sake, if you look at the July precipitation, we've actually seen a decrease. We've seen a shift in behavior into Missouri and into northeastern Iowa. So much of the rest of the state has decreased the amount of July precipitation by 10 to 15%. Okay, so shifting from the observed patterns that we've seen in the trends to some climate projections, looking at temperature and precipitation extremes as we get into the middle of the 21st century. The first plot here is the observed and projected changes in Iowa's temperature, so the annual average temperature. And let me orient you with this plot. It's kind of busy. The orange line is our observation, so the physical observations from our stations across the state. And then we have two scenarios, the higher emission scenario, the lower emission scenario, in which we start cutting back on the use of anthropogenic fossil fuels, looking at conservation practices. So the red gives you the higher emission scenario range of temperature increases by the end of the 21st century. The green gives you the lower emissions range. Well, we can also take those climate models and run them backwards to give us an idea of if the physics and the thermodynamics within the climate models is behaving realistically. So we run those backwards, and this is where you see the modeled historical temperature record within a given range. So this gray bar, when the orange line is within the gray range, it's telling us that climate models are doing a pretty darn good job of replicating what the atmosphere is doing. So as we project those lower emission to higher emission scenario, anywhere from the potential into 2050, so in the next 25 years, of an increase to 2.5 degrees degrees Fahrenheit in the temperature record, up to the potential for 10-degree increase in temperature. Why that's important is I mentioned that the Clausius-Clapeyron equation says that 1 degree Fahrenheit increase in temperature necessitates a 4% more water vapor capacity in the atmosphere. So at the worst case scenario, you're raising the temperature by 10 degrees towards the end of the century. That's 40% more water vapor in the atmosphere to work off of. And that's where we're going to start to see increasingly extreme events that will have impacts on flooding and our conservation practices. You think of that water having to fall over Iowa. If it falls north of us, Wisconsin, Minnesota, all that water drains south. That's where we see aerial flooding, a high probability of aerial flooding as we move into the next several decades. Now, if we look at the broad scale increase in temperature across the United States, the lower emission scenarios here, higher emission is here, anywhere from a 3 to 5 degree increase across much of the upper Midwest, again, tied in with more water vapor, more cloud cover, more rainfall. Now, if we look at seasonally projected precipitation changes, winter, spring, and fall, we see an increase in the amount of rainfall and snowfall that we see. I mentioned earlier, less snowpack in wintertime, so less slow melt infiltration into our soil profiles. If we get into frozen soil profiles and get rainfall on top of that, more wintertime flooding as well. So those are also trends that we look at in terms of frost depth and frost freeze cycles for buried infrastructure as well. Now, another thing that we think about during the summertime is higher humidity. Swamp-like out yesterday before the cold front passed through. But with more water vapor availability in the atmosphere, with changes in the large-scale climate system, we see the Bermuda High becoming stronger, the Rocky Mountain Low stronger, more moisture from the Gulf of Mexico infiltrating into the upper Midwest. And that's where you see higher humidities possible. This has implications on livestock health. Higher humidities give us higher temperatures and higher heat index. We also see more frequent and higher intensity rainfall events within the climate projections that produce these higher humidity scenarios. But also with more water vapor, more cloud cover, we reduce the daily temperature range. So our overnight lows are not getting as low as they could with more water vapor in the atmosphere and more cloud cover to prevent long wave radiation from getting out at night. So higher humidities, more low level moisture to work off of. This does help mitigate some moisture stress in our row crops with the vapor pressure deficit, but it does increase those heat indices that we're seeing. Another thing I get asked often, and particularly this season, we've had over 120 tornadoes across the state, hail and high winds as well in a derecho just last Monday, or 2 Mondays ago. Number of days in which severe thunderstorm environments can occur, we're seeing an increase in that March, April, May timeframe, particularly from Missouri up through Iowa. So the ingredients that we need, more moisture, higher temperatures, more instability, is existing as we get towards the middle of the 21st century. So more potential for severe weather events in spring. But we're also seeing some semblance of a pattern shift, less severe behavior in summertime. And this might be tied into that dip that we're seeing in July rainfall, less thunderstorms, less severe weather. So what the trend is showing us right now, more thunderstorm behavior, March, April, May, with the potential locking that in with higher intensity rainfall events. Now, luckily, I had a great chat with Will Myers and Jake Hansen here at IDALS. In-field conservation practices. So these are some of the management tools that we can use, particularly cover crops. We know that with these higher intensity rainfall events falling on bare soil, it ejects soil. It actually loosens up the soil profile, so we're getting more runoff of our rich soils. We want to keep them on the landscape. So we think of cover crops, we think of rotation diversity, looking at corn and beans and rotation of those crops. Also prairie strips, and I'll get into that. But perennial cover, having cover on our land surface that prevents runoff from these higher intensity rainfall events that we're seeing in all seasons, but particularly late winter and getting into early spring. Structural conservation practices, these address both in-field and edge-of-field practices. So we think of terraces, wetlands, farm ponds. We think of farm ponds as a retaining source of water when we do get into drier conditions. Water and sediment control basins, keeping the water where it should be, but also helping evacuate it from farmland. Then we think of buffer strips, our bioreactors that we've been putting in across the state, and of course, windbreaks. More CO2 in the environment has led to a faster green up as we get into the growing season. So we are seeing, and this goes hand in hand with the wind behavior that we're seeing, higher winds farther up because we have more surface drag on the where we live in the system. So I'll have links to these as well as some additional information. Then we think about urban conservation programs. The infrastructure that we have built, the sewer systems that we have, is not meant for the rainfall that we're seeing. So we're getting a lot more flash flooding with these higher intensity events, and they're happening faster. We think of the June 30th, July 1st, 2018 event across central Iowa. Anywhere from 6 to 10 inches fell on the landscape. So having these tools to help get this water away from urban areas, but also holding that excess water in these retaining ponds basically help to mitigate some of that runoff that we're seeing in the urban areas. So I'm running short on time here, but adaptive options that we can look at, integrating alternative crop species via crop rotation to maintain soil health. We think about biochar and carbon sequestration, also increasing soil porosity, but also soil health for better infiltration of water. Choosing crop species and varieties that are more suited to future conditions, given that we're seeing more water, but also the persistent dry conditions, particularly in July and August. Choose longer maturity corn, but also be prepared with farming strategies that can help manage too much or less less moisture that we expect in the system. Here are the resources available. This is being recorded, of course, and I'll have my contact information at the end. Also want to plug the climate change impacts on Iowa agriculture. This is through a collaboration, again, with the USDA climate hubs and state and federal experts. So this document will address much of the issues that I've discussed in this half-hour presentation. Finally, my contact information. If you have questions and I can't get to them, please send me an email or give me a call, and I'll be happy to get back to you.
All right. Thank you, Dr. Glisan. All right. We'll get to questions, so feel free to type those in. But the next, if you need a CCA, CEU, email Alena Whitaker, ALENAW, at iastate.edu by 5 o'clock today. Include your name, the name you entered to watch the webinar, and your CCA number. Again, ALENAW at iastate.edu. Those of you that need a CCA, CEU have probably done it before and you know who to contact. All right, next slide. Should be our voluntary demographic survey. If you watch this webinar live and are willing to fill out a voluntary demographic survey, we'd greatly appreciate it. iowalearningfarms.org/survey, or you can scan that QR code. Only one response is needed for calendar year 2024 webinars. So if you've done it, thank you very much. And if you're willing to do it for this one, that would be fabulous. And we'll plug the next webinar. We have Sebastian Villarino, who's going to talk about integrating anaerobic digestion with agriculture for improved carbon management. So please tune in next week at noon for that. And then I think maybe the next slide is there one in there that this webinar is archived or is being recorded, as long as my computer worked okay, which it seems like it is. You can find those on the iowalearningfarms.org/webinars or Iowa Learning Farms webinars YouTube channel as well. And somebody asked if we could just go back while we answer some questions to your contact information again. And we do, there we go. Okay, so few questions. First one, can you expand a bit more on the changes in the wind trends? They found this atmospheric thirst concept very interesting. Yeah, that was a new term for me as well.
Yeah, so we think of, in the lexicon of meteorology and climatology, we have all of these derecho, ring of fire, all these phrases. A newer one is rapid onset drought or flash drought. So you think of through the growing season, if you have a soil profile that's being used up with vegetative demand, particularly in summer, that's where you have warmer temperatures, drier conditions, along with windy days. That's where you develop an atmospheric thirst that you're extracting any moisture that you have at the surface. So I mentioned with this article in Nature that with more CO2 in the environment, green up is happening faster. We're also seeing more more plant life at the surface. This has implications on wind speeds at the surface. And now we've had more wind events. We've had several derechos over the last 5 to 6 years. Again, this is tied into atmospheric instability and the wind profile in general. But with increasing wind speeds higher up, you note that we're increasing the amount of wind turbine farms that we're putting out there because we have more basically fuel to work off of higher up. You're also mixing up drier conditions with these low-level wind increase. So I could spend an hour on just this topic. So why don't you send me an email and we can talk offline on that.
Okay. Next one. Do you know of any research projects that have quantified the impact of climate change on surface water temperatures in Iowa?
That's a good question. I can't answer that question. So again, contact me and I will point you to the person that can answer that question.
Yeah. Yeah, I think that's an interesting one.
Now, when we talk about that, just as an aside, we
Yeah.
think of algae blooms in
Mhm.
warmer temperatures with warmer surface water temperatures. So I do know that there has been research on that, but I will get you to the person that can answer.
Okay. Can you expand on the precipitation spatial variability across Iowa, including maybe the seasonal expectations?
Yeah, that's a great question. So I mentioned with warming in the mid latitudes where we live and triple the warming across the higher latitudes relaxes the temperature gradient between the two hemisphere or between the two segments of the northern hemisphere. A more relaxed temperature gradient creates a slower moving jet stream. But we also see more meanders form. We think of the polar vortex or those Arctic air intrusions. We think of the heat domes that we've had over the recent several weeks that have given us 95, 100-degree temperature days, but also have produced the squall lines. They're called ridge riders that ride along those ridges. With a slower jet stream, we're seeing more meanders more often, and that produces more persistent behavior. So if you look back at 2018 and 2019, the record wettest year for the northern third of the state, D3 drought you wouldn't see once but every 30 to 50 years in southeastern Iowa, the jet stream was parked over northern Iowa and southern Minnesota. So that's where we see an increase in that spatial variability of where rainfall and precipitation is occurring. You look seasonally, back at that slide, if I can get there fast, where we're seeing the highest increase are the higher latitudes getting into Canada. So we're seeing the jet stream moving further north. And that's where we're starting to see this drier behavior in the climate modeling. So it's tied in to the way that the jet streams are functioning across the United States. Excellent question.
Are there any updates being made to the NOAA Atlas 14 estimates to represent the change in a 100-year, 24-hour rainfall event? And are the projections based on climate change scenarios? So any
Yes.
update or
Easy question.
input?
Yes, they
Okay.
are currently being updated. I
Okay.
believe we'll have something out this year, later this year.
Okay.
We just the American Association of State Climatologists actually received some information from NOAA on ground truthing this information. So
Okay.
it's in the pipeline.
Okay. Yeah, it seems like that's something that this person updates to these numbers would greatly help in event-based modeling, and I would agree
Abs-
completely. Yeah.
Absolutely.
Um, I guess one of the things I think you mentioned this, but it's I always indicate I have to be careful of relaying one person's observations, but it seems like I grew up in Iowa, been in Iowa for the better part of 50 years now, um, but just seems like more thunderstorm or intense events earlier in the year. I grew up in Northwest Iowa, and it seemed like it was July and August when we'd get these intense events, and now it just seems like it's earlier in the year. Is that just an anecdotal my memory, or has that been happening a little bit?
It has been happening. And you think back, it's an anomalous event, the December 15, 2021 event, a
Yeah,
serial derecho, nearly 70 tornadoes. So December 2021
yeah,
has the distinction of the highest amount of tornadoes on an outbreak for any month for the state of Iowa, and then for December for the United States. So I mentioned that um, wintertime is the fastest warming season, more access to Gulf moisture. You think of the severe weather that we've seen this season, starts along the Gulf Coast, then moves into the mid-Atlantic states, then moves into the Midwest and then the upper Midwest. That behavior generally follows the sun. So a higher solar angle, more surface heating during the day. Uh, we're getting more severe weather events, particularly this year. But you'd have to go back to 2004 to see a tornado season like we've had this season. So we do need more data points to tell us if we are in fact seeing an increase in severe weather uh, overall in spring. But definitely, given that we're increasing the growing window, warmer winters will give us a, a bigger time zone or a temporal scale for more thunderstorm activity as we increase the temperature in the atmosphere.
um, I guess what kind of question here? How does our um, land use, whether we're tilling the soil, our row crops, how have those factors maybe influenced some of the um, evapotranspiration that we see, and how might that influence some of the precipitation patterns that we might see?
Yeah, so evapotranspiration is one of those variables that we look at particularly in the warm season to see the amount of moisture that we're losing from soil profiles, but also, transpiration from corn and beans. If you have cover crops, you look at a bare soil versus a soil area that has residue or cover on it, uh, you're going to lose less moisture because the sun is not able to convert that water into vapor. You're not evaporating from the surface because you have some cover that prevents moisture from being extracted. Uh, so over bare soils, if you look at times of drought with bare soils and no water within the profile, let's say the soybean canopy doesn't close because of moisture stress, uh, you're going to increase the surface temperature as well because uh, that those wetter soils actually help keep things cooler. And if you look at summertime temperature trends, the days in which we've seen 95-degree temperatures is flatlined. And that has to do with how rich our soils are, how much water they can hold, but also the conversion from sensible heat, that actual heat that we can feel on drier soils. When they're wet, it's more latent heat, so it doesn't change phase, and we don't get an energy transfer. Uh, Again, I could talk about that for another hour. I've got a presentation on it, so please contact me if you will.
All right. I think that it pretty much gets to most of the questions there, and I really appreciate Dr. Glisan your willingness to be a repeat presenter on the Iowa Learning Farms webinars. Yours are always well attended and really interesting. And this is Justin's contact information again. Again, if you need CCA CEU, please email Alena Whitaker, ALENAW, at iastate.edu by 5 o'clock today with your name, the name you entered to watch the webinar, and your CCA number. With that, Justin, I'll give you the last word.
Oh, thank you, Matt. It's always a pleasure to present to your group. It's well attended. And next time I'll have my microphone figured out. I've got a podcasting microphone that I use, but I didn't have it plugged in today. So we'll correct that next time.
Nope, no worries. We're good. Okay.
Okay.
Thanks, everybody. Tune in next week for presentation on anaerobic digestion and carbon management. So, with Sebastian.